All right. So today we are talking about solving systems using substitution. So the method is using substitution. Are these my filled out notes? They look like yes. Well, hang on a second. There we go. Solving systems using substitution. So the first thing you do is pick an equation. So you always want to pick an equation that has one of the variables isolated. Okay, has one of the variables isolated, meaning it has an x all by itself or a y all by itself, or choose an equation that you can isolate the variable with one step. Maybe you have to subtract it. Okay, so you really want to look for x equals or y equals. Typically, I try to make all of my equations look like y equals because that's something that we're familiar with. We always use y equals. So you substitute that expression into the opposite equation and you solve. And then you take that value and you plug it back into the other side. Because remember, this is an ordered pair. This is an ordered pair. So you have to figure out the value of x and the value of y. So let's go to this first example. What do you think is going to be easier? Do you think it's going to be easier to get x all by itself or y all by itself? And tell me what equation you want to look at. Anyone? Do you want to use equation number one? Okay, equation number one. You think it's going to be easier to get x by itself or y? Either one of them. So if I wanted to get y all by itself, if I wanted to solve for y, negative x plus y equals 1, what would I do? I would add x to each side. Brain, pick up your pencil and start writing this down. So y equals x plus 1. So I'm going to take this x plus 1 because that's what y equals. Y equals x plus 1. And I'm going to substitute that into the next equation. I'm going to put that into equation number 2. So equation number 2 looks like 2x plus, instead of using y, what am I putting in there in place of y? Yeah, x plus 1 equals negative 2. And now I'm going to combine like terms. I'm going to combine my like terms. So 2x plus x is 3x. So I have 3x plus 1 equals negative 2. 3x plus 1 equals negative 2. Okay, now what? Yeah, subtract that 1 from both sides. And when I subtract that 1 from both sides, I get 3x equals, 3x equals negative 3. 3x equals negative 3. So subtract 1. 3x equals negative 3. Well, if 3x equals negative 3, how do I figure out what x is? Divide by 3. So x equals negative 1. Remember that my solution is an ordered pair. My solution is an ordered pair. So I know that the x value is negative 1. I still need to find the y value. I know that for my solution, x is negative 1, but I still need to find the y value. How am I going to do that? Well, you take what you got for your x coordinate and you plug it into either equation. So we're going to plug x equals negative 1 into equation number what? Do you want to put it in equation number 1 or equation number 2? Number 2. Okay. So 2x, that's 2 times negative 1, plus y equals negative 2. Well, what is 2 times negative 1? Negative 2 plus y equals negative 2. Add 2 to both sides, and I find out that y equals 0. So that's my second number in my solution. Now, what do I have to do to make sure I've done this correctly? Yeah, you have to check it. So here's my check. Negative times my x coordinate, which is -1, plus y, which is 0, equals 1. God bless you. Well, the opposite of -1 is +1. +1 plus 0 does in fact equal 1. Checked it for the first equation. Now I need to check it for the second equation. 2 times -1 plus y, which is 0, equals -2. Well, 2 times -1, that's -2, plus 0 equals -2. And that is true. So, done what I needed to do. Now, that's a lot of steps, right? You got to find x, plug it back in, find y, and then you got to check it. Let's do that again. So, looking at this, equations number 1 and number 2, which one do you want to isolate the variable on? Which one do you think it's going to be easiest to get a variable all by itself? Equation number 2. Okay. Say again. It really wouldn't matter. So I kind of disagree. I think that you can get equation number 1, you can get y all by itself quickly. Equation number 2, when you try to get y by itself, you're going to have a negative y. So that's going to take 2 steps. So we're going to take this equation and we're going to solve for y. So solve for y. So 3x plus y equals 5. Braden, do you want to come and stand by me? Okay, so pick up your pencil and write this down. You're not just sitting here doing nothing. So when I solve for y, I subtract 3x from both sides. Y equals -3x plus 5. So that's my y. So I'm going to take this value for y and I'm going to plug it in right here. I'm going to substitute it in for the next equation. So I'm substituting in. So that's 2x minus, well, y is -3x plus 5 equals 10. What happens when you have a negative outside of a parenthesis? What is that the same thing as? It's the same thing as multiplying by a -1, right? So I want to distribute that negative through my parentheses. So I really have 2x plus 3x minus 5 equals 10. 2x plus 3x is 5x, and I'm going to add 5 to both sides. So 2x plus 3x is 5x. 5x equals 10 plus 5 is 15. Divide both sides by 5. X equals 3. Are we done? No, that's just the x coordinate. That's just the x coordinate of my solution. I have to find the y coordinate. So I'm going to plug it back into one of my original equations. I'm going to plug it into equation number 1. So 3 times x, which is 3, plus y equals 5. Well, 3 times 3 is 9, plus y equals 5. I'm going to subtract 9 from both sides. Y equals -4. So my solution is the ordered pair 3, -4. Are we finished? We need to check it. Yeah. So I'm going to check it. So 3, checking my first equation, times x is 3 plus y is -4 equals 5. Let's see. 3 times 3 is 9 minus 4 equals 5. And that is true. 9 minus 4 does equal 5. Let's check it for the second equation. 2 times 3 minus my y coordinate, which is -4, equals 10. Notice that when I have minus, I put the minus and then my variable term in a parenthesis. Because if you don't, I guarantee you, your brain is going to see that minus sign and just put a 4 there, thinking, oh, I already wrote the minus for the 4. You're going to pass it. You're going to skip it over. So make sure that when you substitute in for a variable, you put it in a parenthesis so you don't make any of those mistakes. 2 times 3 is 6. A negative times a negative is a positive. 4 equals 10. Is 6 plus 4 10? Yes, it is. So this is what I'm looking for a solution. I need to have this, and I need to have this, right? Got to have the check. Okay, let's move on to question number 3. Question number 3 says your turn. Question number 3 says your turn. You're going to try it. So I'm going to start you off. And then I'm going to freeze and take some attendance. So I'm going to start you off, and then I'm going to pause for attendance. So I'm going to freeze the screen. So notice that one of these equations has a variable already isolated. Do you guys see that? Yeah, this already says y equals 3x plus 2. So what am I going to do with that? Yeah, plug it in right there. Okay. So I'm going to freeze the screen so I can get my attendance submitted really fast. Okay, we ready to talk about it? Braden, are you going to try any of these, or are you just going to sit here all day? Just be honest with me. All right, I'm going to unfreeze the screen so we can talk about this. So when I substituted in for my y coordinate in the second equation, I ended up with x plus 2 times the quantity 3x plus 2 equals 11. So I had to distribute my 2. X plus 2 times 3x is 6x, plus 2 times 2 is 4, equals 11. X plus 6x is 7x. 7x plus 4 equals 11. Subtract 4 from both sides. 7x equals 7. Divide both sides by 7. X equals 1. So I'm going to take the fact that x equals 1, and I'm going to plug that into my first equation. Y equals 3x plus 2. Y equals 3 times 1 plus 2. Well, 3 times 1 is 3, and 3 plus 2 is 5. So y equals 5. So my solution is the ordered pair 1, 5, and then I checked it. So y, which is 5, equals 3 times x, 3 times 1 plus 2. Well, 3 times 1 is 3, 3 plus 2 is 5, so that works. When I go to the second equation, x, which is 1, plus 2y, 2 times 5 equals 11. Well, 2 times 5 is 10, and 1 plus 10 is 11. 1 plus 10 is 11. Okay. We're ready to go on to number 4 and number 5. Number 4. Solve by substitution. So when I look at number 4, which one is going to be easier to get x by itself or y by itself? Look at equation number 1. Yeah. Which equation? Yeah, equation number 2. I'm going to take x minus 4y equals -1, and I'm going to solve for x. I'm going to solve for x. So I'm going to add 4y to both sides. Add 4y to both sides. So x equals 4y minus 1. I'm going to take that 4y, that expression that represents x, 4y minus 1. I'm going to plug it into equation number 1. 2x plus 2y equals 3. Well, we just said that x is 4y minus 1, so I'm going to sneak that in there. 2 times 4y minus 1 plus 2y equals 3. I have to distribute. That gives me 8y minus 2 plus 2y equals 3. Let's see, 8 plus 2, that's 10. So 10y minus 2 equals 3. Add 2 to both sides. 10y equals 5. Divide both sides by 10. And I find out that y equals 1/2. Y equals 1/2. So that's the y coordinate of my solution, 1/2. Okay. So now what do you want to do with that? Well, I'm going to take that y equals 1/2 and I'm going to plug it into equation number 1 or number 2. Doesn't matter. It doesn't. I'm going to plug it into equation number 2. Or number 1, sorry. So 2 times 1. Oh, did we just solve for y? Sorry. 2 times x plus 2 times y is 1/2 equals 3. 2x plus, what is 2 times 1/2? Or think of it as half of 2. It's 1. Half of 2 is 1. So 1 equals 3. Subtract 1 from both sides. So 2x equals 2. Divide by 2, which means that x equals 1. Are we finished? Got to check it. Carter, you're going to always remind me to check because sometimes I forget. I do. So 2 times the x coordinate, 1, plus 2 times the y coordinate, 1/2, equals 3. Let's see, that gives me 2 plus 1 equals 3, and I believe that's true, right? Let's check the second equation. Second equation gives me x1 minus 4 times the y, 4 times 1/2, equals -1. Well, half of 4 is 2, so I have 1 minus 2 equals -1. Is 1 take away 2 -1? Yeah, it is. Yes, it is. So we're done with the check. So sometimes you might have a question that says, and I'm going to write it like this, -1 equals -1. You might have a question that says, what did you get for the checks? Okay. So when I did this first check, I got 3 equals 3. And when I did the second check, I got -1 equals -1. That's what I got when I did the checks. Sometimes I'll ask you a question like that to make sure that you're doing the check. And if you do the check all the time, you know exactly what I'm talking about. But if you don't do it, then you're like, what does she mean? And that's really what I mean. I'm trying to catch you off guard. Okay. Let's do number 5. And then we have a word problem. Bring you awake. Okay. So look at this second equation here. I have equation number 1 and equation number 2. The second equation just tells me that x equals 2y. So I'm going to just take that and plop it right there. So 2x plus 6y equals 15. But I'm replacing x with what expression? Yeah, I'm putting 2y in there. That's super easy. So 2 times 2y is 4y. 4y plus 6y equals 15. That's 10. 4 plus 6 is 10. So 10y equals 15. And when I divide both sides by 10, I find out that y equals. Now, it's important to keep your answers as fractions, especially when you do something like this where you could potentially get a decimal answer. This is a nice decimal answer. It doesn't repeat itself. But if you were to take 10 divided by, or 15 divided by 10 in your calculator, how would you take that answer and turn it back to a fraction? I would want a mixed number and one fraction. How would you do that in your calculator? Everybody pick up your calculator and do 15 divided by 10. Calculators. Turn it on, and I'm just going to type 15 divided by 10. Yeah, when I get that, once you get that answer, press your math button. You get the answer 1.5. Press the math button. You guys see it's the third button down from the left? When you see it says number 1, fraction. That's saying, hey, do you want a fraction answer? Yeah, I do. And it tells you 3/2. I just want you to know how to do that, because if you have a terminating decimal like 1.5, it's okay to leave your answer as 1.5. But if you get something like 1.6666666, you can't round for that, right? So you need to have a fraction answer. So y is 1.5, maybe. Y is 1.5 or 3/2. So I'm just going to write that up here. It's my y coordinate, 3/2. Okay. Now, how do I find the x coordinates? Well, I'm just going to take the x equals 2y. I'm going to plug it in. X equals 2 times 3/2. Well, in my calculator, that's just 2 times parenthesis 3 divided by 2, close my parenthesis. That's what I'm putting in my calculator. This is my calculator operation. Okay. And when you do that, you should get that x equals 3. Did we get that? Okay. Are we done? No, we have to do the checks. So check. 2 times x, which is 3, plus 6 times y, which is 3/2, equals 15. So 2 times 3 is 6, plus 6 times 3/2, well, that's 18/2, which is 9, equals 15. And I think that 15 does, in fact, equal 15. Let's check the next one. X, which is 3, equals 3 equals 2 times 3/2. 3 equals 3. Check. That's what your checks are going to look like. Our last one is a word problem. So we have a whole section devoted to applications, but I also try to embed applications throughout the lessons just so you're not like experiencing a huge culture shock, right? So I want you to see applications every single time. So it says the rocket coaster has 15 cars. Some of the cars hold 4 people and some hold 6 people. There is room for 72 people altogether. How many 4-passenger cars are there and how many 6-passenger cars are there? So these are the variables. The first variable, how many, that's the number of 4-passenger cars. So X is the number of 4-passenger cars. That's what X is. The other variable, how many 6-passenger cars are there, sorry. So the number of 6-passenger cars. That's what it's asking you. So those are the variables. The question is the variable. So how many total cars can I fit on this ride? How many cars does the rocket coaster have? Has 15 cars. So that means that the number of 4-passenger cars and the number of 6-passenger cars has to equal 15. How many total people can be on the ride at one time? 72. Room for 72 people. That means that the 4 people per some number of 4-person cars plus the 6 people that go in the 6-person cars cannot exceed, has to equal 72. Those are your 2 equations. Those are your 2 equations. So let's take equation number 1 and solve for y. If I were going to solve equation number 1 for y, what would that look like? What am I going to do actually? We've been solving for y for quite a while. If I'm trying to get y all by itself, what do I have to do? Draw the x to the other side. Yeah. So that's going to become negative. Y equals negative x plus 15. Yeah, just drag it over to the other side. Remember, when you drag it across, it changes the sign. You're subtracting it. So I'm going to take this expression right here and plug that into the next equation. So 4x plus 6 times, well, this is my y value, negative x plus 15 equals 72. All right, so I have to do some distributing, it looks like. 6 times negative x, that's negative 6x. 6 times 15, that's 90, equals 72. 4 minus 6, well, that's negative 2. So I have negative 2x plus 90 equals 72. I'm going to subtract 90 from both sides. Negative 2x equals negative 18. When I divide both sides by 2, I find out that x equals 9. That means I have 9 4-passenger cars. I have 9 4-passenger cars. What am I going to do with that 9? You want to plug it back into the first equation or the second equation? Let's plug it into the first equation. X, which is 9, plus y equals 15. So what does y equal? Say it. Yeah, y equals 6. That means I have 6 6-passenger cars. Braden, pick your head up. Come and stand by me. Come on. I have 6 6-passenger cars. Okay. So now what? Yeah, plug them in and make sure it works. Plug them in and make sure it works. You're good. Just stand right there. I just need you to pick your head up. You're falling asleep. So 9 plus 6 equals 15. 15 equals 15. That's the first check, and it works. 4 times 9, number of 4-passenger cars, plus 6 times 6, number of 6-passenger cars, better equal 72. Let's see. 4 times 9 is 36, and 6 times 6 is 36, and 36 plus 36 is 72. So it works. So the only thing I didn't do yet is write it as an ordered pair. It's a real world problem. So I did give the sentence kind of 9 4-passenger, but still, I want to still give it as an ordered pair, 9, 6. Okay. So your homework is pages 10 and 11. Pages 10 and 11.